the Navy Entomology Center of Excellence, NECE, providing force health protection and enhancing readiness around the world. Preventative medicine and vector control personnel stationed across the U.S. and around the globe regularly trap mosquitoes as part of their mission. Surveillance data yielded from these catches provides the necessary information to take actionable steps to monitor and control mosquito populations, helping people who live and work on military bases minimize their exposure to nuisance pests and disease vectors. Specimens that were trapped in the field are placed in a freezer for up to 24 hours to kill them. The next day, these raw catch specimens are removed from the freezer, ready to sort and ID for further analysis, virus testing, or to determine if mosquito control action should occur. First, you'll need to sort out any non-mosquitoes. Some, like beetles and moths, are easy to sort out. Others are not so easy. Some flying insects have a similar size and general appearance to mosquitoes. Midges, for example, are globally present and are often captured in light traps. Mosquitoes will always have only one pair of wings, scales on their body and wing veins, and will have a proboscis, which is the part they use to pierce a victim to gather a blood meal. If a flying insect, like these midges, does not have a proboscis, then it is, without a doubt, not a mosquito. So, first and foremost, look for a proboscis before comparing other physical details. Next, you should sort out any male mosquitoes from your raw catch. Only females take a blood meal, so there's no need to test male mosquitoes for viruses. And males are not counted to determine if the threshold has been passed for mosquito control, so you don't need to keep any males from your catch. Male mosquitoes can be identified by their very bushy antennae and hairy palps when compared to their less bushy and hairy female counterparts. Take a close look at these side-by-side comparisons of male and female mosquitoes, and you will clearly see the differences in their antennae and palps. The bushy antennae on males are easy to see, so you will probably not need to use a dissecting scope. Keep in mind that female mosquitoes usually emerge as adults a couple of days after males, so if you catch a lot of males in your trap, you can probably expect to trap females in the next day or two. Now that you've narrowed down your raw catch to only female mosquitoes, you will get an overall count of the females to see if they surpass the action threshold to trigger a mosquito control response. You'll also want to know how many mosquitoes are potentially disease vectors, so you'll need to determine if they fall into any of the 3 genera of medically important mosquitoes. Sort your mosquitoes into 4 genera piles: Anopheles, Aedes, Culex, and other for any females that don't have the features of these 3 key genera. For some purposes, entomologists want to know a mosquito's identity down to species, but for most mosquito control work, identification down to genus is acceptable. This is the Anopheles mosquito. Let's take a closer look. Compare its palps to its proboscis. If they are of approximately equivalent length and the proboscis is not curved downward, then you've just positively identified Anopheles. Notice how this mosquito features palps that are significantly shorter than its proboscis. It is not an Anopheles mosquito. And while this mosquito has palps and proboscis of equal length, its proboscis curves downward. This is also not an Anopheles. While we don't have active transmission of malaria occurring in the United States, it's good protocol to separate out Anopheles, and it's relatively easy. If you're in a country with endemic malaria, this group will be much more of a concern. Now that you've identified Anopheles mosquitoes, you will need to see if the remaining female mosquitoes from your raw catch are from genus Aedes, Culex, or some other genus. First, if a mosquito from your remaining raw catch has iridescent or metallic coloring, it's not an Aedes or Culex. Sort it into your other group. Next, using a dissecting scope, you'll need to look at the shape of the abdomen and some other features to properly ID your remaining specimens. Look carefully at the scales on the upper side of the wing veins. If the scales are broad and flat, the mosquito is not an Aedes or Culex. Sort these into your other pile. Aedes and Culex mosquitoes have narrow, thin, and long scales on the dorsal side of their wing veins. Now examine the shape of each mosquito's abdomen towards the tip of the mosquito. If the sides of the abdomen are relatively parallel all the way down, ending in a squared-off or blunt shape, it might be a Culex. Aedes abdomens taper down to a point. However, if the mosquito has dried out, it might look blunt regardless. So this characteristic is not always 100% trustworthy. Therefore, the next, more reliable step in separating your remaining raw catch specimens is to look closely at a specific area called the mesothoracic spiracle. This is a little respiratory hole on the side of the thorax about halfway between where the wings attach and where the thorax meets the head, above where the legs attach. Look just in front of that hole, called the pre-spiracular area, and just behind that hole, the post-spiracular area. You're looking for little hairs called setae. Pay attention to where the setae actually attach, not just where you see hairs. If you don't see any patches of setae attached directly in front of or behind that hole, and if the antenna length is about the length of the proboscis, the mosquito is in the genus Culex. If there is a little patch of setae attached only in the area directly behind that hole, but not in front of it, it's a mosquito in the genus Aedes. If you see any other setae configuration, you'll put that specimen into your other pile. There are quite a few other genera of mosquitoes you might find, but these characteristics will help you sort your mosquito catch into these important groups accurately. To review, mosquitoes with a straight proboscis that is roughly equal in length to its palps are Anopheles mosquitoes. Anopheles mosquitoes often have patches of dark scales on their wings, not just on their wing veins. Mosquitoes with a pointed rear and setae attached only directly behind their mesothoracic spiracle are Aedes. There are two species of Aedes that are easy to identify without using a scope or lens. Aedes aegypti has a lyre-shaped white marking directly behind its head. And Aedes albopictus has a thin single white stripe from its head down the center of its thorax. Each species of Aedes mosquito usually has stripes at the joints of their legs and colored markings that start at the base of each abdominal section, even on the underside of their abdomen. Mosquitoes with abdominal sections that are parallel all the way down and end in a blunt tip have equal antenna and proboscis length, and no setae attached directly in front of or behind the mesothoracic spiracle are in the genus Culex. Culex mosquitoes are often a solid brown or black color, usually without colored markings on their body and no colored bands on their legs. Positively identifying mosquitoes to the level that we need is not as difficult as you might expect when you know what to look for. Remember to always look for a proboscis and scales on a single pair of wings on captured specimens in order to remove any non-mosquitoes from your raw catch. Sort out any male mosquitoes by looking closely at their antennae. Sort out Anopheles by looking for long palps. And finally, sort your remaining catch of female mosquitoes by separating them into the two genera of main disease vectors, Culex or Aedes, or into your other group by using the genus-level identifying traits. Accurate mosquito identification data will help you and your team protect fellow military service members, families, and base guests from annoying pests and terrible diseases. Together, we can provide force health protection and enhance readiness around the world.